Why do we breathe oxygen? Especially, and you may not know this, when oxygen is killing us. So this doubles down on the question, why do we breathe oxygen? Let's take a dive into metabolism. Join me. Learn Your Body, a science-based education. Oxygen is a molecule in our atmosphere, and our lungs take it in to be deposited into our red blood cells primarily. Once there, oxygenated blood finds its way to our tissues composed of cells, and these cells take up the oxygen bound to the red blood cells. All right, some light cardiopulmonary physiology out of the way, let's get a bit more detailed on the subcellular level. Within the cells that have just taken up oxygen from the blood cells, the organelle known as the mitochondrion exists, depending on the cell, but most of our cells have mitochondria. The mitochondrion is made up of two membranes that's separated from the cytosol, the rest of the inside of the cell. These membranes are creatively called the outer and the inner membranes. Embedded in the inner membrane of the mitochondrion are a series of proteins that serve a vital function in metabolism. These proteins, in concert, are called the Electron Transport chain, or ETC. All right, back to oxygen though. Oxygen, now inside of our cells, travels through the outer membrane and inner membranes of the mitochondrion and ends up on the inside face of the mitochondrion. Here, the molecule interacts with the aforementioned ETC. You see, without getting too much into the thick of things, the ETC is pushing electrons, which are subatomic particles, from one protein to the next, hence the name Electron Transport. This electron pushing serves a purpose, but at the end of the chain on protein 4, called complex 4, or its more complicated name, cytochrome C oxidase, oxygen takes up the electrons at the end of the chain and also picks up two hydrogen atoms to form metabolic water. It's just water, good old H2O. So, does this mean we're sucking up oxygen from our atmosphere just to create water? No. Oxygen plays its larger role in being a suitable place to dispose, a bit like a recycling system, of the electron that's been used by the other proteins of the electron transport chain. This use of the electron pushed from one protein to the next allows the overall ETC to generate ATP, adenosine triphosphate, which is cellular energy. So the oxygen plays the necessary janitorial role on the back end to keep the ETC functioning by disposing of the spent electrons. And in doing so, the cell brilliantly produces water. How cool is that? Obviously, I've glossed over the role of the ETC and how it functions because it doesn't add much to your understanding of oxygen's role. But I did mention this before, especially, and you may not know this, when oxygen is killing us. So, what the hell, Nick? Well, for that, I'd encourage you to check out my next piece of content, and I'll tell you why this brilliant system is still killing you. Talk to you there.